Hello everyone, how are you? I am Teacher Janice and welcome to Learning Math is Fun. So I have something new to share with you guys. Do you want to know what is it? So come on everyone and learn with me. Are you guys ready? So this is about geometric sequence. We are going to focus on how to illustrate geometric sequence and differentiate the geometric sequence from an arithmetic sequence. So now, are you ready? Well then, let us have this memory check. Great, and students, you can ask your member of the family to please join and play with us. So this is just a very simple activity entitled Divide and Conquer. All you need to do is to give or find the ratio or the quotient of the second number to the first number that will flash on the screen. To make it more fun, you can give as fast as you can the correct answer, and the fastest one that will give the correct answer will earn the point, and the one who will earn the highest score will win this game. So are you now ready? That's good. So now let us check how good your memory is. Mother, father, brother, sister, and you grade 10 students, get ready for the first question. That is 5 and 10. What is the ratio? Good job. That is 2. We have 20 and 40. The ratio is 2. 40 and 80. You must write if you give the ratio of 2. 1 and 3. The answer is 3. That's great. 9 and 27. You are correct if your answer is 3. And 27 and 21 and 81. The answer is 3. So good job everyone. So let us make it more complicated for the last two questions. 1/4 and 1/2. What is the ratio? You are right if you give the answer of 2. And then for the last question, we have 1/2 and 1. The ratio is 2. Very good. Okay. All the answers in this drill activity are examples of ratio. I hope guys you were able to give all the ratios in this activity. By the way, how will you define ratio? When we say ratio, that is a relationship between two quantities normally expressed as the quotient of one divided by the other, as what we did in our drill activity. So your knowledge in this ratio is a prerequisite skill in our lesson, geometric sequence. So of course, you must master how to divide numbers or integers. It will be easy for you to obtain our objective today if you mastered how to divide the integers or how to get the ratio. Any question? Well then, if you have no question, let us have learning task 1. In this task, you are going to determine if the pattern illustrates geometric sequence or not. We are going to assess how far you know about geometric sequence. So let us try. In example number 1, 5, 10, 20, 40, and 80. Will you be able to give the answer of geometric sequence? For number 2, 3, 6, 9, 12, and 15. You must answer not a geometric sequence. Then for number 3, 1, 8, 1, 4, 2 1/2, 1, and 2. You are right if you give the answer of geometric sequence. 1, 3, 9, 27, and 81. You are very good if you give the correct answer of geometric sequence. And then for the last question, you have 10, 9, 8, 7, and 6. Is it geometric sequence or not? That is not a geometric sequence. So, how did you find the activity? How did you identify if the given pattern illustrates geometric sequence or not? What have you noticed on the given patterns? I know very well that you are familiar with the patterns in items number 2 and number 5. That is because the pattern 3, 6, 9, 12, 15 illustrates arithmetic sequence. That is because of having a common difference of 3 and the number or the next number obtained by adding 3 to the preceding term. And for number 5, 10, 9, 8, 7, and 6, of course, you know that very well that that is an example of arithmetic sequence. That is because the common difference is negative 1. That is from 9 minus 10, the answer is negative 1. 8 minus 9, the answer is negative 1, and so forth. Very good. What about numbers 1, 3, and 4? What have you noticed? That's great. You will observe that the next number could be obtained by multiplying fixed number to the preceding term. That's good. Okay. Well then, in the previous activity, those 3 patterns are examples of geometric sequence. So we have noticed that the next number could be obtained by multiplying the preceding number by a constant number. So in geometric sequence, that constant number multiplied to the preceding number to obtain the next is what you call the common ratio. So what do we mean by geometric sequence? Geometric sequence is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number, which is called common ratio. That is also known as geometric progression. So let us take a look at this example. In number pattern 1, 2, 4, 8, 16, that is an example of geometric sequence. So let us try to prove that this is a geometric sequence based on its definition. So we must obtain the common ratio. So let us try to get the ratio of 2 and 1. That is 2. 4 and 2, the ratio is also 2. 8 divided by 4, the ratio is also 2. And then 16 divided by 8, the answer is 2. So, we have proved that the common ratio is equal to 2. So now, let us determine the next 2 terms in the given sequence 1, 2, 4, 8, 16. So in this sequence, the first term is 1, the second term is 2, the third term is 4, the fourth term is 8, and the fifth term is 16. So, the next 2 terms must be the 6th and the 7th term. According to its definition, we can obtain the next term by multiplying the preceding term by the common ratio. So, let us use this. To get the next term, the preceding term of the 6th term is 16. So 16 times the constant number is equal to 32. So our next term to 16 is 32. And for the seventh term, the preceding term is 32 times the common ratio of 2. Then the seventh term is 64. So therefore, the next two terms are 32 and 64. So what do you think are the 8 and the 9 terms of the sequence? You are right if your answer is 128. That 128 is obtained, which is the preceding term. 64, that's right, and the common ratio is 2. So 64 times 2, the answer is 128. What about the ninth term? Okay, the ninth term is 256. That's correct. And that is obtained by multiplying 128 by 2. Then you got it, 256. Is that clear? That's good. Are you still there? Good. So, going back to learning task 1, try to prove that 5, 10, 20, 40, 80, and the rest 2 patterns, geometric sequences. So let us take a look at the ratio of the first pattern. So you have 10 divided by 5. The ratio is 2. 20 divided by 10. The ratio is also 2. And then 40 and 20, the ratio must also be 2. And then 80 divided by 40, the quotient is 2. So again, there is a common ratio. So since we have the common ratio of 2, so we have proved that number 1 or 5, 10, 20, 40, and 80 is a geometric sequence. So what do you think will be the next term? That's correct. It should be 160 because of 80 times 2 is equal to 160. So let us proceed to pattern 1/8, 1/4, 1/2, 1, and 2. We must get the common difference. 1/4 divided by 8, you must have a ratio of 2. 1/2 divided by 1/4, the answer is 2 also. Then 1 divided by 1/2, we also have 2. And then 2 divided by 1, the answer is also 2. Again, we got a common ratio of 2. How are we going to multiply or divide fractions? So let me see if you can still recall how to divide fractions. Okay, so let us take a look at 1/4 divided by 1/8. In dividing fractions, you're going to get the reciprocal of 1/8, then multiply it to the numerator 1/4. So in this case, we have here 1 times 8, the answer is 8. And then 4 times 1, you have 4. Then you have 8 divided by 4, the answer is 2. Then 1/2 divided by 1/4, get the reciprocal of 1/4, so you have 4 over 1. And then you are going to proceed to multiplication. You are going to multiply the reciprocal of the denominator to the numerator 1/2. So 1 times 4, the answer is 4. And then 2 times 1, the answer is 2. So you have the quotient of 4 halves, and then 4 divided by 2, the answer is 2. Okay? Then what about 1 and 1/2? What is the reciprocal of 1/2? That's good. That is 2 over 1. Then 1 times 2 over 1, you have 1 times 2. The answer is 2. And then 1 times 1, the answer is 1. So 2 divided by 1, the answer is 2. So that's how you are going to divide the fractions. Again, we're going to get the reciprocal of the denominator and then multiply it to the numerator. Any question? So let us proceed to pattern 139, 27, and 81. So in number 2, we have proved that that pattern illustrates geometric sequence because of having a common ratio and the next term obtained by multiplying the preceding term by a common ratio of 2. In the next pattern, let us prove that they have a common ratio. So let us take a look at 3 divided by 1. So we have 3. 9 divided by 3, the answer is 3. Getting the ratio of 27 and 9, we got 3. Ratio of 81 and 27, you also got 3. That's correct. So as you can see, the common ratio is 3. And we can obtain the next term by multiplying the preceding term by 3. Okay? So see, we have proved that those 3 patterns illustrate the geometric sequence. Any question? Okay, very good. So now, take a look at this example. 3, 8, 13, 18, and 23. In this sequence, there is no common ratio among the terms. However, if you are going to get the difference between the next number and the preceding term, there is a common difference of 5. So let's say you have 8 minus 3, you have 5. 13 minus 8, the difference is 5. 18 minus 3, the answer is 5. And 23 minus 18, you got it 5. So, what do you call the sequence? That's right. That is an arithmetic sequence. That is because the next number is obtained by adding a common difference to the preceding term according to its definition. Okay? So, do you have any question? So, if none, let us take a look at this another example. So, we are about to finish. Negative 20, 10, negative 5, and 5 halves. So, there is a common difference of negative 1 half. So, let us prove that the common ratio is negative 1 half. So, we have 10 divided by negative 20. So, as you can see, there is a common factor of 10 in the numerator and the denominator. So, you have 10 divided by 10, so you have 1, and then negative 20 divided by 2, divided by 10, the answer is negative 1 half. Then the next two terms, you have negative 5 divided by 10, so you have the common factor of 5. So, negative 5 divided by 5, the answer is 1. And then 10 divided by 5, the answer is 2. So, since you have the negative sign, the answer is negative 1 half. And for the last two terms, 5 halves divided by negative 5. In this case, again, you encounter fraction. So, again, you are going to get the reciprocal of the denominator. So, what is the reciprocal of negative 5? So, that is negative 1/5. Multiply it to the numerator. And then, as you can see, there is a common number 5 on its opposite position. So, you have to cancel 5. Then, 1 times 1, the answer is 1. And then, you have 2 times 1, the answer is 2. Copy the negative sign. So, the ratio is negative 1 half. So, we just prove that the common ratio is negative 1 half. And this sequence is a geometric sequence. Is that clear to everyone? Do you have any clarification? That's good. So let us take a look at the last example. So this is the last example. Okay, in this example, 6, 12, 14, and 28, we are going to determine if there is a common ratio or common difference so that we will identify what type of sequence is this. So first, we are going to look for the common ratio. In finding the common ratio, we are going to divide the next term to the preceding term. So we have 28 divided by 14. The answer is 2. Then another 14 divided by 12. The ratio is 7/6. And then we have 12 divided by 6. We got a ratio of 2. As you can see, the ratio of the first two terms is not equal to the second ratio. That is not also equal to the third ratio. So therefore, the given sequence is not a geometric sequence. So if it is not geometric sequence, let us try if there is a common difference. In finding the common difference, we are going to subtract 28 minus 14 rather. Then the answer is 14. Then 14 minus 12, the difference is 2. And the last one, we have 12 minus 6, the difference is 6. Again, we will observe that their differences are not common. So since the first difference is not equal to the second, that is not also equal to the third difference, then the given sequence is not an arithmetic sequence. So meaning, we prove that this sequence is neither an arithmetic nor geometric sequence. Okay? Are you still listening? That's good. So, if you have any question, you can raise question or you can chat or text me if you have any clarification regarding this geometric sequence. Okay then, so let me see if you have understanding regarding geometric sequence by having this activity. In this activity, you are going to determine if the given sequence is an arithmetic, geometric, or neither. If they are arithmetic, you are going to state the value of the difference or the common difference. If they are geometric, you are going to state the common ratio. Is that clear? Okay, so I hope you are still there. Okay, for this example number 1, 6, 12, 18, and 24. The answer must be... That's correct. That is an arithmetic sequence because the common difference is 6. What about this one? 6, 11, and 17. Do we have common ratio? What about the common difference? That's right. So that is neither an arithmetic sequence nor geometric sequence. And for 2, 14, 98, and 686. That pattern is a geometric sequence. That is correct because of having the ratio of 7. Okay, so let us have this 160, 80, and 40. You got it right if you answered geometric sequence because of having the common ratio of 1/2. Okay, for the last question, we have here negative 14, negative 25, negative 10, and 5. So the answer must be... arithmetic. That is because the common difference is 15. Okay, so I hope everyone answered them correctly. So if you have no question, I hope you're still there. Kindly get your module, work on learning task 2. You're going to determine the common ratio in the next 3 terms of the following geometric sequence. You're going to write your answer in the space provided, and of course, you're going to use another sheet of paper for your solution. Item number 1 is done for you. Take note of this, class. You must show your solution for you to earn points for this activity. Of course, you must have this answer. There you got it. Okay, next. If you are through, then you're going for task B. This case, you're going to translate the word I love you very much in French by determining and matching the common ratio or common difference of the following and then placing each letter in the spaces below the decoder. So, again, you are going to show your complete solution for giving you corresponding points. So, you must answer this one. Okay, do you have any question? Okay, if none, I hope you have learned something about geometric sequence. So God bless everyone. If you have any question, you can chat, text, or call me anytime. So if you want this presentation, you can just write your email on the comment box. That's all. God bless everyone.